What's going on, everybody? This is GeoWes, and welcome to the new playlist. It's called Python Noob. As a disclaimer, I just want to let you know that if you're listening to this expecting expert advice, as the name of the playlist says, I am a noob to Python. But if you're here to learn with me, then you found the perfect playlist for you. So in this first episode, we'll be covering the introduction to Python, and our source material is by Code Quickly. It's called Learn Python Quickly. And obviously this playlist will end up probably being longer than the book, but this is to get kind of a base level knowledge of programming in general. My extent of programming knowledge is pretty much, I knew HTML when I was like 12 years old, and past that, don't have much of a programming background, but we'll get into why I want to learn Python. So the foreword. Python is one of the most popular syntax languages. It is powerful, robust, easy to use, and combines a diverse toolkit with an intuitive syntax. And what the F is a syntax? A syntax of a computer language is a set of rules that defines the combinations of symbols that are correctly structured statements, expressions in that language, and it applies to both the source code and markup languages. How do you start completing your own projects? How do you move from a beginner to intermediate? We're going to be going step by step, learning the basics and building on those basics to move towards more advanced topics. We will begin by covering the basics of the Python syntax, such as variables, operators, data types, data structures, and then we will move to intermediate topics like functions, modules, object-oriented programming, advanced Python techniques like recursion, image manipulation, and unit testing. We'll also look at open source Python libraries. The final parts of this book will cover two different programming projects that will encompass all that we have learned. The first project is a story idea generator that will help you understand how to manipulate text and reinforce basic programming principles. The second project is more challenging. It's going to be a weather application that will help you learn how to work with outside data, manipulate it, present it in a user-friendly format. Python is easy to use and learn, but also flexible and powerful. It's used in everything from mobile application development to DevOps to machine learning and artificial intelligence. You can increase types of jobs you'll be able to apply to and be successful. Yeah, this playlist hopefully will make you rich. Python can automate filling out a spreadsheet. It can help you develop a website. It is very popular in data science. So geology in Python, and I linked where I got this particular information, geologyinpython.com. We'll probably end up following some of the tutorials on that website to kind of learn how to create these types of this normal fault model right here, which is pretty cool. This looks like terrain, geologic map, three-dimensional, and this is using QGIS or ArcGIS, probably ArcGIS, to create these models. So Python can be used in geoscience and geophysics. There are tools to quickly load, analyze, plot, report geological data, spatial data in multiple dimensions. You can manipulate arrays and scientific data using NumPy and Pandas, which I'm guessing are Python packages. Matplotlib, which is one I've heard of before, and Mayavi make it possible to visualize a function with one line of code and then customize it with a variety of methods and other packages. You can use it to create stereonets and ternary diagrams and probably analyze those particular diagrams. You can use it, and this is one of the main reasons I want to learn it, is for GIS. You can use it to read, write, and manipulate rasters and vectors in Python. Well, in Python. QGIS is completely written with Python, from what I understand. So knowing Python will help me understand QGIS better. Python can be used in remote sensing and geophysics, and it is also used in machine learning, and Python is the top language allows to predict and estimate using complex algorithms. So the main reason I want to learn it is basically I want to learn how to groundwater model, and Python is a way to develop groundwater models. I would also like to use it for the GIS, like I said. And also, I've already looked it up, and you can use Python. You can program it to take a lab report, a PDF lab report, and turn it into an Excel table for, instantly. And that would really automate, a lot of the inserting data into an Excel sheet, Excel table. That would make it quicker, basically. So chapter 1, introducing Python. So Python was created in 1990 by Guido van Rossum, which is a badass name. It has a general purpose, and it's a high-level programming language. It can be used on a variety of operating systems like Macintosh, Windows, and Linux. Python supports several packages and modules created by other developers to make development of Python applications quicker and easier. Python is versatile, intuitive, clean, and has a readable syntax and structure. It supports structured programming and object-oriented programming, as well as functional programming, and I had to define these because I didn't know what they meant. Structured programming is a programming paradigm aimed at improving the clarity, quality, and development time of a computer program by making extensive use of the structured control flow constructs of selection, if, then, else, and repetition while and for, block structures, and subroutines. Object-oriented programming is a programming paradigm based on the concept of objects, which can contain data and code. Data in the form of fields, often known as attributes or properties, and code in the form of procedures, often known as methods. And then functional programming is a programming paradigm where programs are constructed by applying and composing functions. It is a declarative programming paradigm in which function definitions are trees of expressions that each return a value rather than a sequence of imperative statements which change the state of the program. So introducing Python, it comes with a robust standard library of modules, functions, and tools. Every module is a powerful tool you can use without developing additional code. It comes prepackaged with modules that assist in creation of various web services, manipulating strings, working with operating systems interface. And what the F is a string. A string data type is a data type modeled on the idea of a formal string. Strings are such an important and useful data type that they are implemented in nearly every programming language. In some languages, they are available as primitive types, and in others as composite types. The syntax of most high-level programming languages allows for a string, usually quoted in some way, to represent an instance of a string data type, such as a metastring. Such a metastring is called a literal or string literal. So basically, let's find one that has the quotation marks. This picture doesn't look like it has it, but we'll see it in a future slide. And that's basically what a string will be. From what I understand, it'll be just a line of code like this, separated by an enter. So it's easy. Python is easy for users to create libraries and frameworks. It has a large open source community. It's simple but can also carry out complex scientific math tasks. It can simplify and analyze data. You can have machine learning models and artificial intelligence. So you can use it to model a fault, in geology, or model a contaminant plume in groundwater, because that's going to involve complex math. Okay, and in terms of the version we'll be using throughout this playlist is version 3.7. So installing Python, and I'll have a little video pop up about right here to show you how to download it, but you just go to that link and download it. I mean, I'm sure you guys know how to download a program, but we'll be defining over these next few slides the interpreter, the compiler, the terminal, the shell, and the IDE. So interpreter versus a compiler. So an interpreter, and I go more in depth in this because I didn't understand it when I was writing this. Interpreter, a computer program that can execute code carrying out written instructions specified by a programming or scripting language, carries out code immediately and direct. A compiler, in contrast, a program that translates instructions to efficient machine code. And I used this particular source, pandabunnytech.com, to kind of learn more about the difference between these two terms. And you can see on this table on the left, it kind of goes over the differences between the two and more in depth. By now, you already know that source code needs to be converted into machine code before it can be run by the computer. This is because at its most basic level, a computer can only understand strings of numbers that specify different operational codes. Writing code at this most basic level can get ridiculously complicated, and so today we use programming languages to make our nerdy little lives a lot easier. Because the programming languages devised by humans are only understood by humans, the source code we write must be translated into machine code before the computer can execute it. How the programming language is translated into machine code depends on whether the source code language is a compiled language or an interpreted one. So, compiler versus an interpreter, what's the deal really? With interpreters, there will be no new files containing machine code created. Unlike a compiler, an interpreter will work on the fly, going through your source code instruction by instruction and handling instant execution. And I'll let you guys read through the table right here. So a compiler, and an example is C, C++. I've heard that language can be difficult to learn, especially if you're a noob like myself. If you're using a compiled language like C or C++, you will write your source code and then use a compiler. A compiler goes through your program source code and then creates a file, sometimes called an object file or an executable or an exe file, as most of you would know, that contains your newly translated machine code that can be processed by the computer. You can now send your program, your executable file, to anyone you wish to share it with, and they will be able to run your program directly on their computer. Also, you get to keep your source code yourself without sharing it with the users of your program. So an interpreted language, which PHP, JavaScript is considered an interpreted language. When using an interpreted language, you will be converting the source code into machine language beforehand. Instead, you will be sharing a copy of your source code to the users of your program, and their computers will interpret the code when running your program. So instead of translating the source code into an executable before running it, an interpreter converts the source code into executable machine language on the spot while the program runs. An interpreter translates source code into machine code, combining it with runtime libraries before executing the code instantly during the program runtime. A runtime library, or RTL, is a collection of low-level software used to activate functions and services that are native to the computer on which the program is being run. So a shell, and the way I understand shell is basically everything, inside the dialog box is a shell. So I'll just read it. So a wrapper or an environment whose primary function is to run other programs, often used to refer to command line of an operating system. A shell script is a computer program designed to be run by the Unix shell, a command line interpreter. So if you open your command prompt, going to type here to search, you search the command prompt, that pops up. That's basically the shell. The various dialects of shell scripts are considered to be scripting languages. Typical operations performed by shell scripts include file manipulation, program and execution, and printing text. So a shell is a common command line interpreter which exposes access to an operating system's services. In general, operating systems shells use either a command line interface or a graphical user interface, depending on a computer's role in particular operation. It is named a shell because it is the outermost layer around the operating system. The command line takes in commands, and here's a picture of the shell. That's basically what it means. It's just a little complicated. So command line takes in commands centered around name of applications the user wishes to interact with. Interface, the image to the left, is an example of a Python shell running interpreter. Python has its own shell, an interactive interpreter specialized for running Python commands. Lets the user execute code and see results as soon as a user enters the command. And this picture on the left is the Python shell. We'll be defining a terminal, and the Python shell that can be accessed through the command line is an example of a terminal. And the terminal is an environment that allows users to input text. So up here, this is your terminal. And down here. And to input text and receive outputs. So in a Python interpreter, there are two main ways to work with Python, with the interpreter and command line, and with an integrated development environment, or an IDE. Most would be done with an IDE, but let's understand how to work with the Python and terminal first. So this is in the terminal, this is in the IDE. So you can get a lot more complex coding in the IDE, whereas in the command prompt, you're pretty much limited to just a couple single lines, So step one, we'll open up the terminal command prompt and check Python is installed correctly by typing Python and here's a picture of my command prompt. I just typed Python. I put the quotation marks from what I understand you don't have to get this information to pop up for you. The command prompt should transition you to an instance of the Python interpreter shell. This interpreter allows you to write and run Python code. So step two, type into the command prompt print, and literally exactly as it's typed right here, past the three arrows, you just type that in and it'll send this back to you using the terminal interpreter. That's basically what print does, and command print is responsible for printing out to the terminal whatever is specified inside the parentheses. Python interpreter. Most programming is done in IDE. The Python interpreter can typically be invoked from the command line by entering Python or the version you run, which is Python 3.8. You can exit this particular shell just by typing exit with the parentheses or quit with the parentheses, depending on the version you have. The help command, which I typed right here. Actually, I just typed help and it popped up for me. Oh, no. Okay. Yeah, I typed help with the parentheses and it showed me various commands and functions that you can use in the interpreter. So when you enter a command by hitting enter key, the statement will be evaluated for correct syntax. If there is a syntax error, the error will be displayed. Python is waiting for a command. If you see the primary prompt, which is often indicated by the three arrows as we saw on the previous slide, if on the second line of input, it'll be 3 periods, basically. And this is what a syntax error will look like in the shell. So using an IDE, you can't preserve many lines of code on the interpreter and terminal. Your errors will be thrown immediately. IDEs make the process of learning a language simpler because they highlight syntax errors for you. Auto-completion for certain key phrases, functions, easier collaboration with other programmers, ability to make changes to run a script while the program runs, are positives of an IDE. One excellent IDE is, and this is the one I downloaded to use for hopefully this entire series, is called PYCHARM, and you can download it at that link. An open source IDE designed for Python highlights syntax errors, enables easy refactoring, renaming of files, comes with an integrated debugger, which is pretty cool. So code refactoring, just in case you are wondering what refactoring is, because I did. Code refactoring is the process of restructuring existing computer code, changing the factoring without changing its external behavior. Refactoring is intended to improve the design, structure, and or implementation of the software while preserving its functionality. So PyCharm has also an integrated terminal, and when you run programs, results of programs execution will be displayed in terminal or well, at the bottom of the IDE. So, well, actually, I couldn't screen record. So, first step is to install it at that link that we just saw on the previous slide, and you press New Project, and it asks to select an interpreter, and you see right here, Virtual Environment. You can stay there on the default. It should auto detect your base Python interpreter if it is correctly installed on your computer, which it was for me. So you create a new folder here on the bottom left. You create a new folder to hold your scripts you create by right-clicking in the project frame and choosing New. And then you can create a new Python script, right-click on the folder you just created, and navigate to New, and then Python file, and then enter the name of the file. It should auto-open in an editor panel to the right, and you can enter your code into the editor. So using PyCharm auto-saves, so that's a good thing. If you have a freeze, and you won't lose any of your data, your coding. Once you have written some code and want to try running it, you can either navigate to Run. So actually, on mine, I can just right-click and run my Python script, which I call ploppers. So you don't have to go to File, Run, or anything. You can just right-click and press Run ploppers, or whatever you called your file. Or you can press Shift F10. I know a lot of people prefer that method using shortcuts. PyCharm provides functions you can use to edit and control your code. Example, you can find specific bits of code by using the Find option, Control F plus Shift. You can search an entire project for a block of code. The debugger can be activated by right-clicking, and it's the same thing. Debug is right here, right below Run ploppers. It'll be debug ploppers. And you can select the debug command or Shift plus F9. PyCharm will flag parts of your program where problems have been spotted, which I've tested this program out a little bit, writing some things. It's pretty cool how it basically corrects you as you're writing your code. It's constantly running it just to make sure it's input correctly. It also allows you to set breakpoints, which are points at which your program will be paused, which allows you to see how your data in your program has been manipulated up to that point. So features like code completion and auto flagging of potential errors and formatting problems. Code completion feature is a predict text feature that will analyze your code as you type and create drop-down menus with possible options that you could use to complete your code. And Code Monitor will alert you to possible formatting and syntax errors, which will be underlined in red. And some other good IDEs, if you don't want to download PyCharm, is Spider, PyDev, Idle, and Wing. So we won't go over this in this episode, maybe in the next episode. But good programming practices, it's highly advised you learn the Python style guide and follow it as you write code. PEP8, and you can follow that link, is the style guide that lays out the best practices for writing your code. These suggestions include when to use tab spaces, how to format important statements, suggested naming conventions for variables and classes, etc. Why follow this style guide? To help others and to help yourself. Allow others to read your code. Avoid ambiguous and confusing syntax, and clarity of your code will assist other programmers in interpreting its purpose and functions. It will help aid you in understanding your code and makes it easier to come back to a program you wrote a long time ago and understand it. PyCharm will notify you when you have broken certain PEP8 guidelines. So writing comments in Python, which this is simple, but I went through it, and I think I have a video to play. But anyways, try replicating the code and running it. And I just typed it exactly as you can see in the picture. I typed it exactly as the book gave it. Hashtag. This is an example of a comment. Hashtag. The code below prints out a statement, and then I should have put another space after statement to have print as its separate line, because I put print as a separate line on this. Notice the first two lines are ignored and are in dark gray. Hashtag means number sign or hashtag, however old you are as a listener, means anything that follows is a comment. Python ignores, they aren't part of the commands that make up a program, typically used to leave notes for yourself and other developers. It aids in the understanding of the purpose of the code. Highly advised you add comments as you follow along. Explaining a chunk of code will help you learn and better understand what commands accomplish what. And then I do have a video for this, I believe. But you can create multi-line comments by using triple single quotes to open and close comment blocks like so. And then you just put three single quote, and then you type out your comment lines, which you don't have to type exactly comment line 1, 2, 3. You can randomize your comments, and then you just end it with 3 single quotes. So thank you for watching. The next episode will cover variables and operators, and I might also include a review of the PEP8. I'm going to go through that because I definitely want to understand it. So the PEP8 is basically a tutorial on how to cleanly write code in Python. Like I said, thank you for watching, my fellow Python noobs, and hope to see you guys on the next episode.